Today we start our topic on data. Now, the people that collect data are generally called statisticians, and there's a whole process that they have to go through before they can collect data, and in fact after they've collected the data. So let's write down some of these points that are on the board here. The first thing that they need to do is write surveys. Now, that involves really thinking hard about what types of questions to ask. Do they want to ask questions that make people feel uncomfortable? No, because then no one will want to be in the survey. So they need to ask good questions that keep people within their comfort zone and make them feel like they're being respected and valued and allowed to give their opinion freely. Now, questions need to have a suitable type of option for the answer. So it needs to be really clear when you ask a question, whether it's a yes-no question or whether you're asking how much someone agrees with a statement. And in fact, when you're writing questions, you need to imagine what you're going to do with the answers. Because if you're writing open-ended questions where people get to write long sentences and you get 100 sentences in, you've got to ask yourself how you're going to process that data. So sometimes asking yes-no questions or questions like how much do you agree with this, where people get to tick a box, makes it a lot easier for you to analyse the data afterwards. And of course, respecting people's privacy, as we mentioned, really important. Now, generally when we collect data, it's because we're trying to conduct research about a certain population. So when we use the word population, we use it not just to mean everybody that there is in the world. It could be, say, the population of our school, which would just be the people at our school, or the population of people who live in Mittagong, or the population of dogs that live in my yard. It could be any population that you like, and you get to define that. Now, if you're researching a whole population and it's got a lot of items in it, there could be people, there could be something other than people, then it could take you a ridiculously large amount of time and could be completely impractical. And that's why statisticians choose a sample group from a much larger population to participate in the study. So if, for example, I wanted to find out what Oxley students thought about a certain thing, rather than asking all 800 Oxley students, I could perhaps choose a sample of 80 students from kindergarten to year 12, making sure that I've got a good distribution of ages in there. And what they tell me will give me a good idea about what everybody thinks without having to actually ask everybody. So that's what we mean by a sample. It's a smaller group out of the population, which is inherently the larger group that you're interested in. Then you have to collect the data, and if it's a survey, that means asking people questions. It could be counting cars as they enter a car park. It could be anything involved with data there. You need to organise and display it, because if you don't display data so that people can understand what it means in an instant, then it's kind of wasted. No one has the time to actually pore over tables full of figures. We like to see graphs and things like that that tell a story really as quickly as we look at them. Now, if you think of data as information that you get when you study something, then you can break all data up into two main types. Either it's data that's based on numbers, and we call that numerical, or it's data that's based on categories, and that's called categorical. Now, we can break both of those types into two more types. Now, nominal data just means that it's data that has been named. So examples like blue, green, colours, these are named categories, and they could be the answers to some survey question that's been asked. Whereas ordinal categorical data does have some kind of order to it. So it denotes that something might be higher or lower than something else. Examples of data might be low, medium, or high as the answers to some sort of question that you've got. Numerical data has numbers in it, of course, but you can generally break it up into things that you count, and that's discrete data, and that means that you'll only have generally whole numbers as answers, 1, 2, 3, 4. For example, how many pets do you have? There'll be whole numbers. Whereas continuous data is generally things that we measure. And the reason it's continuous is because it comes down to the accuracy of your measuring equipment to say, well, what accuracy are you going to here? For example, if you measure somebody's height, this is continuous data, because if you tell somebody how tall you are, they might say, oh yeah, that's to the nearest centimetre. What about to the nearest millimetre? So you might measure a little bit more accurately and say what it is to the nearest millimetre. Someone else might have a measuring equipment that measures to the nearest tenth of a millimetre, and so on and so on. And if you start dividing tiny increments up into even tinier and tinier increments, you could divide them potentially infinitely. Now, nobody has the ability to measure height to millionths of a millimetre, and in fact, why would we? We wouldn't care. But the notion is that as soon as you're measuring something, whether it's lengths of time or weights or volumes, heights, anything at all, it really comes down to how accurately you're going to measure it. And there's an infinite number of responses that you could get to the question, how long or how tall or how large is that thing? Now, occasionally it can be slightly confusing working out what type of data you've got. For example, if you're asked what size your shoes are and you say size 8, well, you might be thinking that you're counting sizes 1, 2, 3, 4. On the other hand, size 8 is kind of a category of size of shoe, isn't it? It's not as though it's actually 8 centimeters long or 8 inches or anything like that. It's not really a measurement, and it's not really a counting. It's more of a category, and it's actually ordered. And it's ordered in that you know that a size 8 shoe is generally larger than a size 7, and it's smaller than a size 9. And if you've got data that you're pretty sure is categorical, but you can't quite decide whether it's named or it's actually ordered, here's the way to tell. When you go to make some sort of graph with it, for example, if I was graphing the eye color of everybody in our class, is there any reason that I would necessarily choose to put a column for, say, blue eyes or brown eyes? Is there any reason to assume that one should go before the other? Not really. And if you can't tell which thing really should come first, other than maybe writing them alphabetically, then it's definitely nominal data, because it's really just the name of the color of your eyes that you're interested in. Whereas if there's some sort of order to it, and it makes sense to graph the smaller thing first and then the larger thing, that tells you that it's probably ordinal data.